Okay, so today, quick notes, and then I want to hand back quizzes. For those of you that haven't finished your quiz, I want you to go either take it or finish it, and then time for some homework so that you can get, use the compasses for homework and stuff like that. And so lots of stuff going on today. Okay, just a reminder that your test is Thursday. Actually, your test on this stuff, on these instructions, is this week Thursday. Okay, all right. Here we go. So we are on page 24 in your note packet. Okay? Apparent lines are given. One is the pre-image and the other is the image. Okay? So line AB is the pre-image. Line A prime, B prime is the image. Okay? Define the transformation used to create that image. What are we thinking for a transformation? Do we remember, first off, what our three transformations are? Translation. Okay, what's a translation? You just kind of move it up, down, left, and right, right? Is this an up, down, left, and right moving kind of a thing? Okay, so translation, out the door. Okay. Rotation and reflection. Okay, is this a reflection? How do we know it's not a reflection? They wouldn't intersect. The lines wouldn't intersect. The lines would be parallel because it would be a reflection. It's kind of like looking in a mirror. It would just be off a little bit. Okay, so that means it's a rotation, right? Process of elimination is what you're going to get from this. Love it. Okay, all right. So by process of elimination, it is a rotation. Okay. Now, let's talk angle, because one of the things with a rotation is we got to have a direction, an angle, and a point that we rotated around, right? It's kind of like the center of rotation. So let's talk angle. It appears to me that the slope of AB is positive 1/2. Would you agree with that? To go from B to A, I went up 1 and right 2. So that's a rise of 1, a run of 2. That is a 1/2 slope. Agree? Okay, all right, love it. It appears to me that the slope of A prime, B prime is -2. To go from A prime to B prime, we went down 2 and right 1. Yes? Okay. What can you tell me about those two lines? Why, Grace? She gave you the word why. Why are they? They are positive 1/2 and -2 are opposite reciprocals, so they are perpendicular. Okay? Which means that this angle right here is how much? That means that that is 90 degrees. Perfect. Okay? Which direction did we rotate? Counterclockwise, right? Okay, because we're not going the same way that a normal clock would go. We're going counterclockwise. Okay? Which point did we rotate around? -1, 3. This point right here where the two lines intersect. So this would be a rotation 90 degrees counterclockwise about -1, 3. Yes? Same thing. More mathy to say about. Okay? Love it. Okay? Write an equation for the graph of each line. Okay, well, we went through the point -1, 3, right? So then my blue one would be y equals 3 plus 1/2 x minus -1 would really be x plus 1. So I get y equals 1/2 x plus 7/2. Agree with me on that? You come up with the line for the A prime, B prime. What was the slope of line A prime, B prime? -2. What's the y-intercept? 1, right? Couldn't have done that on the other one because it didn't cross at a point, right? This one crossed at a point. Now, if you did that, if you still did all of that, you still would have gotten down to this answer, right? If you would have gone through point slope. But that one we were given a good y-intercept that we knew. Okay? Love it. All right, let's get into it. Regular polygons have rotational symmetry. They can be inscribed in a circle, okay? Meaning that they can be, there's a circle, and we did this the other day. We did it, we gave you the center point of the polygon, and then you took the compass and you extended it out to the vertices, and you made the circle around, right? Okay? So that is inscribing a polygon inside of a circle. Okay? The circumscribed circle has its center at the center of rotation. Actually, no, that would be the circumscribed. Inscribed circle would be, it goes inside the, in for inscribed. Sorry, I got that wrong. I went circumscribed, inscribed. I don't, it really doesn't matter. Truthfully, it doesn't matter if you're putting the circle inside or if you're putting the circle outside. It just matters how big your radius is. Okay? Center is the same. Okay? So we gave you a sketch of one. Okay? All right? So now what we're going to do is we're going to find that center. Okay? And you can find that center as the intersection of the diagonals. So if we draw in all 3 diagonals, excuse me, I said diagonals. The other word, diameters, because we don't do all of the diagonals. My fault. Okay? It's the intersection of the three diameters. So you need to draw the three diameters that we have here. Okay? So all the way across the hexagon 3 times. That gives us our center point. So to circumscribe a circle, we take and we put the pointy end at the center. Expand it out. And then if you're a tippy topper, oops, I was off by just a little bit. If you're a tippy topper holding the compass up top, or if you're a page spinner, either way, works both ways. You should get a circle that goes all the way around. It hits every single vertex. Yeah. Now, one thing that I will tell you is that a hexagon consists of 2 equilateral triangles. There's one equilateral triangle. And there's the other equilateral triangle. Okay? Which is all of the diagonals then of a hexagon. Okay? So in order to construct a regular hexagon inside of a circle, okay, we need to construct 2 equilateral triangles inside the circle. Okay? Here's how we go about doing that. First thing that you got to do you're going to draw any diameter. Okay? What's a diameter again? All the way across the circle. What do we call the middle point? The center. Yep. Okay, so it's all the way across through the center. That was key. Because if we go all the way across and not through the center, then that's called a chord. Okay? All right? So all the way across through the center. So it doesn't matter which one or where or how it looks. Okay? It just has to go through the center one time. Okay? Then, with your compass, you're going to measure the radius. Okay. So, pointy end on the center, expand your compass out, until you hit the edge. Once you have that radius, then you're going to make a swoosh from one end point of your diameter. So you're going to move the pointy end down to one end point of your diameter, and you're going to swoosh it. Now, I'm going to label some points here. So this was point A, this was point B. Okay? So we went to B and we swooshed, right? Okay? Should go through the center, and then that creates points C and D. Okay? Right now, as we stand, triangle ACD is an equilateral triangle. Okay? So we've created one equilateral triangle. If we were to connect A and C, C and D and A, we would have an equilateral triangle. Okay? But we want a hexagon. So now we have to go to the other end . We're going to go to the other end point and swoosh. That's going to create points, what am I at? E and F. Okay? Here's your hexagon. AE, C, B, D, F is your hexagon. Oh, that's fine. Which would also make triangle BEF an equilateral triangle. Yeah? Good? Now, the last construction that we have is we want to, and this is on the last page, I believe, yep, okay, is we want to construct a parallel line through point C parallel to AB, okay? So that again is we want to be parallel to this pink line, but we want it to be through point C. Okay? So in order to do that, move my compass. In order to do that, the first thing that you are going to do is, now, if the potential exists, wink, wink, nudge, nudge, the potential exists that this could just be some random point. We want to make a line parallel to that line through some random point. Okay? Now, when I say wink, wink, nudge, nudge, where do you think that that's going to show up? On the test. Okay? Okay? All right? So if that's the case, the first thing that you do is you draw in BC. Okay? Here it's already drawn for you. Okay? But if not, you need to draw that in. Okay? So that you have an angle that you have set as a set measurement. Okay? The next thing that we're going to do then is we are going to copy angle ABC at point C. Okay? So we're going to copy this angle here at point C. Okay? Refresh my memory, we've copied angles already. How do I go about copying an angle? Arc first, because it's not a line. Okay? What? So we need to swoosh the angle, right? Okay? Okay? We swoosh the angle at point A and at point C. I don't know why my computer is suddenly going slow. Okay? Then what? Measure the arc opening. So I'm going to put it between my two purple dots. So I'm going to measure my purple dots, that opening. Okay? So I'm going to measure my original opening. Then I'm going to point C, right? No, I don't want anything. It's red. So I'm going to go down to point C with that opening, and I'm going to find that intersection point. Come on. Never go. Whoa. Why didn't that work? far enough on my original one? No. Did I move something? I swooshed it. Oh, I went to the wrong spot. That's why. Duh. 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 Not at point C, goofpot lens. At point D. Duh. Those would never intersect. There we go. Now they intersect. There we go. I really don't know why my computer is like lagging behind there. Okay? And then we connect. And now those lines are parallel. Okay? Questions, comments, concerns, clarifications? I want to give you the last half hour of class here now to be able to work on homework and such. Okay? All right?